gonna go ahead and do 3.3. It's properties of functions. This first part is just kind of definitions. So let's get started. And blank function f is one for which f of negative x equals f of x for every time x in the domain of f. Oh. And blank function f is one for which f of negative x equals negative f of x for every x in the domain of f. Whew. Okay. If it comes out positive, it's even, because they're putting a negative in for x on both of these. If it comes out positive, it's even. If it comes out negative, it's odd. Even functions have graphs that are symmetric with respect to the x-axis. No, because if it has symmetric with the x-axis, it's usually not a function, first off. But our even functions, because x squared is an even function, it has symmetry with the y-axis. So let's find that. The given statement is true. It's not true. False. False. It's the only one that says true. Given statement is false because even functions have graphs that are symmetric with the line y equals x. We're not talking about obliques. The given statement is false because even functions have graphs that are respect with the origin. That's odd. The given statement is false because even functions are symmetric to the y-axis. So that just gave away this next one. An odd function is symmetric with respect to the origin, because if it is with the x-axis, it's usually not a function, because if you can fold it across the x-axis, it's not going to pass that vertical line test. Okay, where's my pen? Is f decreasing on the interval 1 to 3? So right here, these are x values. When they give you this interval, it is x values. These are the biggest questions I get that are the hardest for me to explain because it's a visual thing. So we're looking from 1 to 3 because it's the x values. So from 1 to 3, it is increasing there because this graph, this blue line goes up. They asked if it's decreasing. No. Next one, same graph. Is f increasing on the interval 0 to 5? So we're looking at 0 to 5. Remember, these are the x values. X values. 0 to 5. So x is 0 here, and it's 5 here. It decreases, it increases, it decreases. If they ask if it is doing just one thing and it does a lot in that, it's no. It's decreasing from 0 to 1, it's increasing from 1 to 3, and it's decreasing from 3 to 5. They don't separate it out, so it's no. I think there's one like this on the test, and it makes me sad. How many people miss it? List the intervals on which f is increasing. Remember x values. X values. So we're going to look at this graph. Let's pop it up big. And we're looking for increasing, correct? Yep. So we're looking for where it goes up. Down, so from here all the way to here. That is an increasing interval. Our x values in those spots are -7 and -1. So where do we want to write that? Let's go right here. From -7 to -1, it is increasing. Then we decrease from -1 to +1, but then from +1 up to 3, we are increasing. The reason I'm using brackets is because it is a filled-in dot and it is equal to. Then it decreases from 3 to 6, and then we go from 6 to 8. So there are 3 spots where this graph is increasing. When you're looking at increasing, you're just, if I put my pencil on it, this is down, this is up, this is down, this is up, down, up. Keep it simple. Don't overthink this. So these are increasing intervals. Let us go ahead and do that. When we type these in, type your answer, use a comma to separate answers as needed. I don't think we have to use the union sign. -7 to -1. Let's try not using it. Okay. Bracket 1 to 3. 6 to 8. Okay. Don't have to use the union sign. Use the graph of the function f given below to answer the questions. Is there a local minimum at x equals 1? Scoop this here. There's two parts. So local minimum at x equals 1. So first go to where x is 1, right here. This is the minimum at -1. This is the local maximum. Oh, it says is there a local maximum at x equals 1? Yes. And then, is there a local maximum at x equals 1? We already said yes. What is it? Select the correct choice. So when x is 1 here, the y value is also 1, so they want that y equals 1 there. So y equals 1. The maximum height that it got at that x value is 1. I was wondering why I had so many problems on this set. It's making sense now. They're pretty short. List the values of x at which f has a local maximum. Select the correct choice below and fill in any answer boxes within your choice. Values of x at which f has a local maximum. Maximum, they said max. So it's 16 there. Why is 16? That's not what it's asking. But they want to know this x value, so we need to make sure we know what they're going by. Are they going by ones? 1, 2, 3, 4, 5. Yes, so 10, 11, 12. At x equals 12. And then also at x equals, that's going to be -4. Because it's the same height at both of these. If one of these was higher, it'd be that one. And then if it asked about local minimum, pop back up here. Our local minimum would be down here at -16, at +4, and -12. Because it can ask about minimums and maximums. Absolute maximums and minimums is when you see the entire graph. Like there's endpoints on your graph and you know that's as high as it's gonna get. Since we don't have endpoints on our graph, we can't know the absolutes. Do they want this as an ordered pair? What are the local maxima if they exist? Select the correct choice. This is our y value right here. They don't want it as a, so the highest it got was +16. Lowest it got was -16. Select the correct choice. So this graph right here, we see the beginning, we see the end. So when they ask about absolutes, we know because we can see the entire graph. Find the absolute minimum of f on -9 to 8. So that -9 to 8, that's just the interval of this graph. Don't worry about that. So our absolute minimum, what is the lowest spot on this graph? It is right here. They want us to type this as a function. So first, let's go ahead. Our x right here is -7, and then that low point is -1. When we go to type this in, remember that our x goes here, and then our y. So x is going to go in here, and then y is going to go there. I circled that point. Okay. -7 and then -1. I keep expecting it to ask me more questions about that graph before just moving on. Use the given graph of the function f in the following. The intercepts, the domain range, intervals on which it's increasing, decreasing, or constant, whether it is even, odd, or neither. Here we go. So first is intercepts. Our intercepts are going to be -1, 0, 0, +2, and then 1, 0. Domain and range, so our domain is gonna be our x values. So from left to right, we'd have -3 to +3. And then we're gonna have our range. And it's gonna be our y value, so our first y value is 0. And it's gonna go to positive, not here, all the way to the top of the graph. It's gonna be at 3. Let's go ahead and type that in, and then we'll come back and do our intervals. So we have -1, 0, 0, 2, and 1, 0, commas, parentheses. Our domain is -3 to +3 with brackets. Our range is 0 to 3 with brackets. Alright, increasing, decreasing, constant. We do not have a constant on this graph. A constant's when it's gonna be a flat line, just straight across constant. So first, we have decreasing right here. This interval's decreasing because if I was following it, it's going down. So from -3, I'm gonna write, I guess they want increasing first. So I was just starting left to right. So increasing, decreasing, and then no constant on this one. There's no flat line. So our increasing intervals then, these are all our changing points. So we increase from -1 to 0. That's our first one. Then it goes back down, and then from 1 to 3, it's also increasing. Okay, decreasing from -3 to -1. And then it increases, and then we decrease right here from 0 to 1. And then there's no constant. The graph is increasing from -1 to 0, comma, be sure you put your comma between it, and then 1, 2, 3. Okay. Decreasing, we decrease from -3 to -1. An extra button there. And then 0 to 1. Then there's no constant because we do not have a flat line. Lots of marks. Went a little crazy. Now, remember from the very beginning, we were talking about the symmetry and it being even or odd. So if it's symmetric with the y-axis, it's even. If it's symmetric with the origin, it's odd. So this graph right here has symmetry with the y-axis. Since it is symmetric with the y-axis, it is even. Part 1 of 7. Oh, intercepts, domain and range, intervals, even or odd, neither. This one's an either. Our intercept is the only point that is on that graph because the x-axis is down here. It's not going to get there. There's an asymptote right there. When there's a red dashed line, it's called an asymptote. So the point that is on there, that is our only 0, 7. Our only intercept. Domain and range. When I look at this graph for my x values, the first time I come into contact with it, I have an arrow. The next time I come into contact with it at the end of the graph, it also has an arrow. So our domain is going to be negative infinity to infinity. Our range, on the other hand, is going to be different because of that asymptote. So the range on this one, when we're coming bottom to top, the first time we come into contact with this graph is going to be at this value. It's never going to equal this value. It's going to get infinitely closer to this, but it will never equal it. And that's 6. So our range is going to be 6 to infinity. What's the next question after this one? Intervals on which it's increasing, decreasing, or constant. This graph, when we see it, it's already starting to go up. It doesn't have any big changes. This graph is always increasing. So increasing from negative infinity to positive infinity. That means there's no decreasing, there's no constant because it can't be multiple. And we always read our graph from left to right. So if I started tracing this graph, it instantly goes up. Okay, so let's go ahead and do this. The range is parenthesis because it's never going to equal that. Oh, parenthesis, not 9. 6 to infinity because asymptotes are where it's undefined. That'd be like our fraction rational ones that we were solving domain and range for. There's something there that prevents it from equaling that. Okay, the graph is increasing on our graph is increasing always. It will never not be increasing, which means it cannot be the other options. So there's no interval on which this graph is decreasing. There's no interval on which this graph is constant. This graph has no symmetry. It's not symmetric with the y-axis and it's not symmetric with the origin because the origin's down here. So this is neither even nor odd. Using the graph of the given function f, find the following, the intercepts if any. So our intercepts right here, we're gonna have negative pi 0. It goes through the origin. And then we're gonna have positive pi 0. Domain and range, it has endpoints there. So our domain is gonna be negative pi, and since it has that endpoint, it's equal to it, to pi. Our range, our y value, so our lowest y value is negative 8. Our highest y value is positive 8. Intervals on which it's increasing, decreasing, or constant. We'll type these in first. Parentheses, negative pi. Origin, comma, positive pi. Yay. Domain is going to be bracket negative pi to pi. Range is going to be negative 8 to 8 because we look at our y values. Okay. Decreasing and increasing. So the first one they ask about, I'm just going to write up here, increasing, decreasing, constant. There's no constant. It's not flat anywhere. So from negative pi to negative pi over 2, that's down. So that's going to go here. Then it changes directions, and from negative pi over 2 to positive pi over 2, it is increasing. So right here we're going to have negative pi over 2 to positive pi over 2. And then from positive pi over 2 to pi, it is decreasing again. So comma pi over 2 to pi. So decreasing, increasing, and constant. So this graph is increasing from negative pi over 2 to positive pi over 2. Right. Go. But decreasing from negative pi to negative pi over 2. Bracket, comma, bracket, positive pi over 2. Click out, comma, pi. Bracket. Just tedious. Okay. There's no flat line on it, so it is not constant anywhere. I think I have one where we have some constants. But this graph, not symmetric with the x, not symmetric with the y, but if I took this quadrant and rotated it 180, it is symmetric with the origin. If a graph is symmetric with the origin, it's odd. This is question 3 at the very beginning. Using the given graph of the function f, find the following. The numbers, if any, at which f has a local maximum. What are these local maximum values? The numbers, if any, at which f has a local minimum. What are these local minimum values? Okay, since it has our arrows at the end, that's why we don't have absolute. Our local maximum is going to be right here. This is our local maximum. How do they want us to do it? So local maximum, they want x, so our x value here is going to be pi over 2. And then when they ask for what that value is, it's going to be 3. Because our local highest spot, max, this is our max, this is our min. Okay. Pi over 2, because that is the x value there. And then our y value, the local maximum value, is the y value 3. And then on the counter part of that, they are asking for the minimum. Our minimum was at negative pi over 2, and our minimum value is negative 3. So negative pi over 2. And that value, when it's negative pi over 2, is negative 3. Determine algebraically whether the given function is even, odd, or neither. So when we're determining if it's even, odd, or neither, we're going to put negative x in there and see if it's going to equal our equation or equal the opposite of it. And if it's not the same or the opposite, it's neither. So here we go. We put a negative x in here. This is just notation. It doesn't change. That's what we do. And we're looking if it comes out positive, like nothing's changed, it's still this, then it's even. If it comes out and all the signs are flopped, it's odd. I think I'm making it more confusing saying that. Okay. So we put a negative x in to the 4th power plus 5 and a negative x in here squared. Okay, so we're raising it to a power, so I have a negative times a negative, positive times a negative, negative times a negative is positive. So when I raise a negative to the 4th power, it's going to be positive. And then when I raise this negative, I square it. A negative times a negative is a. So is this the same as this? Yes. Seven x squared, so we're gonna put a negative in there, so we're gonna have 7 times negative x squared plus 4. Since this negative is squared here, when we square the negative, because we're just working with our negative, we'd end up with the same thing as that. So this one is also even. I sure hope I put one of each of them on here because that wouldn't be fun. Here we go. So we have -2, and we're going to put our negative x in here, plus the absolute value of 6. This would be a negative x now. So let's go ahead, a negative times a negative here would be 2x, plus, and this would be the absolute value of -6x. But when you take the absolute value of something, it's still going to be positive. So since this sign didn't change, this is going to be neither. It changed our first one, but it didn't change the whole thing. So, okay, well, where's that? Find the average rate of change of f of x equals 2x squared plus 1 over each of the following intervals. Okay. So from 4 to 6, we're going to plug in. I don't want to do this. We got to work it out with 4 and 6. So we're going to do 4, and then we're going to have 6. So we're going to have 2 times 4 squared plus 1. So 2 times 16 plus 1. Then here we're going to have 2 times 6 squared plus 1, which is 2 times 36 plus 1. 2 times 36 is 72 plus 1 is 73. And then when we subtract it, when you do 73 subtract 33, so we're plugging in those values and working it out and then determining how much changed. Oh crap, I forgot to pour it. And then you divide it by 6 subtract 4. So this was the average rate of change on the top. But then we have to divide this by, so it's going to be 40 divided by 2, which is 20. Last two problems, we're doing the average rate of change here. So just like when we did slope before, the y2 minus y1 over x2 minus x1, we're going to have to plug in these values into this for our top, and then we're going to have to divide it by the difference of these two. So let's go. We have 3 times 4 squared plus 1. I'm trying to decide how I want to write this for y'all to see, because technically the whole equation, if I wrote it out, but I don't work it out this way, is why I wasn't going to do it this way. This is what we're doing in the grand scheme. How I do it is I go and I find this number, and then I find this number, and then I do this part. So let me show you that. So we're gonna have 3 times 4 squared, which is 16, plus 1. 3 times 16 is 48, plus 1 is 49. And then I have 3 times 6 squared is 36, plus 1. 36 times 2 is 72. What's 72 plus 36? 108. So I have 108 plus 1, so this would be 109. But I find these two to avoid like trying to work it out in that. So I'd have 49 subtract 109 over 4 subtract 6. So 49 and 109, their difference is 60. So I'd have a negative 60 and then 4 subtract 6 is negative 2, and then negative 60 divided by negative 2 is 30. Okay, let's do another one. So we have negative 2 to 0, so I'm going to have 3 times negative 2 squared plus 1. So that would be 3 negative 2 squared is positive 4, plus 1, 3 times 4 is 12, plus 1 is 13. Okay, then we have 3 times 0 squared plus 1. So anything times 0, so this one's 1. So I have 13 subtract 1 over negative 2 subtract 0. Is 1. And remember that we subtract these two and we subtract these, just like on our slope we subtract. 13 subtract 1 is going to give us 12. Negative 2 subtract 0 is a negative 2. 12 divided by negative 2 is negative 6. Yay. Okay. So 2 to 5, we're going to have 3 times 2 squared plus 1. And then our other one's going to be 3 times 5 squared plus 1. So 2 squared is 4. So 3 times 4 plus 1, 12 plus 1 is 13. 5 squared is 25. 3 times 25 is 75, plus 1 is going to give us 76. And then 2 and 5, so I'm going to have 13 subtract 76 over 2 subtract 5. 13 subtract 76 is 63 negative. And then this would be negative 3. That's going to be a positive because negative divided by negative 21. The big thing on this is that formula. Like, you got to plug it into this with both numbers, subtract them, but divide it by the difference of those numbers as well. Oh, this one looks worse. So we're going to do negative 3 to negative 2. So I have negative 3 cubed subtract 8 times negative 3 plus 1. So negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Negative 8 times negative 3 would be positive 24 plus 1. So negative 27 plus 24 is negative 3 plus 1 is negative 2. Or I could have said negative 27 plus 25, whatever. And then we're going to do negative 2 cubed subtract 8 times negative 2 plus 1. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16 plus 1. Negative 8 plus 16 is 8 plus 1 is 9. Ha! Okay, so I'm going to have negative 2 minus 9 over, and since I did this one first, we're going to do negative 3 subtract negative 2. Negative 2 minus 9 is negative 11, and then negative 3, and when you subtract the negative you add, would be negative 1. Negative divided by a negative is a positive. My ear is hurting. More. Oh, I'm going to have to get a calculator out. Okay, we have negative 1 cubed subtract 8 times negative 1 plus 1. And then our other one is going to be 4 cubed subtract 8 times 4 plus 1. But negative 1 cubed is negative 1. Negative times a negative is a positive. -1 plus 8 would be 7 plus 1 is 8. Easy peasy. 4 times 4 is 16 times 4 is 64. A -8 times a 4 is 32. Add 1. 64 subtract 32 is 32 plus 1 is 33. Okay, so I have 8. That's not an 8. 8. Ha! 8 subtract 33 over, and since 8 was with -1 subtract, and this is 4. Okay, 33 subtract 8 is 25, right? 25, 26, 27, 28, 29, 30, 31, 32, beautiful. And then -1 subtract 4 would be a -5. 25 divided by a -5 is a, oh, this is negative. Because 8 subtract 3, so this is +5. Ah. 5. Woo! Okay, this is the one I think I need the calculator. Since 4 is in this one as well, I'm not gonna work that again. I'm gonna go ahead and do my 7 though. So I'm gonna have 7 cubed, subtract 8 times 7 plus 1. Because I have the 4 is gonna be the same for that, so I'm gonna leave the 4 there. Okay. 49 times 7. I'm pretty sure it's 343, but I don't remember. Because 7 times 9 is 63. 7 times 4 is 28, 29, 30, 31, 32, 33, 34. Yeah. Just didn't want to miss it. 343. 8 times 7 is 56. Plus 1. 343 subtract 55. I think this is going to be harder than me than the other one. Okay. Boop, boop, boop. 2, carry the 1, 14. Carry the 1. 5 to 13 is 8. 5 to 13 is 8. 288. Subtract 33 over 7, subtract 4. Since my 7 was on this side and 4 is on that side. 7 and 4. 288 subtract 33 would be 255. 7 subtract 4 is 3. I'm doing so much math. All right, 3 goes into 25 8 times because that's 24. Remainder 1, and then 3 goes into 15 5 times. Use a calculator. I think that's the most math I've done, like actual multiplication times tables in a second.